right here currently we have two axial flux pulse motors. Got a counter rotator. It works really, really good. So let me get this thing started. Alright, so I mean, since I lowered it, it hasn't missed a beat yet. It's awesome. Alright. Yeah, the grip is really strong on the plate right now. So that's what I wanted to talk about or discuss is how to, without glue, make this aluminum plate stay, maybe a little bit of glue, a little bit. See, that's awesome. Counter rotator works magnificently. Boom. But I'm trying to get, we're working on Faraday's disc, but like an inverse method of it. We're not trying to spin the conductor, we're trying to spin the magnets around the conductor. That makes sense. And then I need to decide what kind of brush we're going to use for the centre and the edge, the center. So, and then if these magnets, because there's a second piece to this that goes on the top, and it syncs up, like couples with the magnets below. And puts a heck of a load on the motor though. Alright, so let me show you the second. This looks exactly the same. It just rests on the top. It is basically the same thing. So it'll sync up. But yeah, let's just try that. Alright, so they're synced. But there's no way that disc is going to stay like that. But if it's been like that and the fields would pass through the aluminum disc, if I could somehow get it to start. But I don't think that's going to happen with it this close together. Now if I back it out, I can get it to go and couple, but it won't like be perfectly coupled. It's you know, lots of ideas floating around here. I need a taller shaft too, because this is like resting on the top, and then it's really kind of wobbly at the top. Oh my lord. So yeah. And then the brush should contact the center of the disc and the edge of the disc. And then yeah, that's the other part that I don't really get. Hello. What's up, Matt? How's it going? Trying to figure out how to couple these without stopping the motor. I mean, I got different kind of magnets here that I might need to get to use here. These ferrites seem a little bit less intense. But yeah, I think I would lower it so that I can get this on there. I gotta raise that coupler. So like right there. But see, when I do that, you get a nice even distribution here, but you don't, it doesn't go all the way through. So yeah, there we go. Yep, it doesn't even go all the way in. Well, I guess we can lose like 2 millimeters farther down, maybe. Now the drive coil is like a Litz wire coil of 20 gauge and 26 gauge. It's 26 gauge trigger, 20 gauge drive. It's pretty sweet when it's engaged. But the way I did it is I just twisted the wires together in series and put some electrical tape over them. So I don't consider that to be a good connection. It works most of the time, but sometimes it just, when it's laying there, it doesn't work. And I think it's because of the way I put it together. But I am planning on getting a soldering gun. So those things, that'll change. Alright, so this kind of syncs up a little bit. And if you just nudge it along, right? I can only imagine what's going on with this disc right now, but I think my magnets aren't the right geometry. They're cubes, and that only takes up, you know, 1 inch of that disc, and there's like 3.5 inches, 3 inches for you to take. You need something like this, so it'll go closer to the center. I'll have to make a new rotor, but you know, right now this is good enough for testing, I think. Let's turn it on. Let's turn it on. 6.5 volts. Let's see. Nice, it's going. So it'll work at this distance, but it's not coupled the way I want it to be. But it is moving. They're both moving. This is north facing up and south facing down. So but you can see how it shakes with it being way up there. Yeah, I'll get a closer look. Sorry. All right, so we got 2 magnetic fields. We got a south on the top and a north on the bottom. You know, with a conductive disc in the middle. I still have yet to make the commutator device, but it shouldn't be too hard. And then this is the counter rotator. This is one of my favorite ones. It runs on a transistor. The other ones are all reed switches. It just needs a little nudge, but it'll start going. Let me just show you. You can see it start to nudge itself in the other direction on its own. See, it's stuck on something though. I thought if I pushed it slowly and it started to pick up speed, that would look more awesome. So these are both axial flux designs. Magnets are all facing down, and there's 3 coils on the device facing up and down. This is Litz wire coil, the one I was just describing. And it's all taped together, but it's 26 gauge and 20 gauge. And it's in a infused iron PLA bobbin. It's 16 feet. Well, like, it's just that many turns. It's just from one wall in my room to the other. This one, yeah, it runs on 24-volt battery. The only thing that's keeping it in place is the shaft here. Alright, hold on, I'm going to put this down. I'll show you what's under the hood here in a second. Apologies. Alright, so the axial flux design, the magnets are facing up and down. This is what's under the hood. You got 3 wedge-shaped coils of 20 gauge and 32 gauge. Right now the 32 gauge is not active. It usually runs with 2 transistors, but it keeps blowing the transistor now for some reason. But it runs pretty good with just the 1 strand. Yeah, so the 20 and the 32, I was planning on having it be its own trigger, but it didn't work out that way, so here's a trigger coil. All that together in series wasn't right for a trigger, so I think they are, well, not lithium ion, but nickel metal halide batteries. Yeah, I'm gonna have to remake this plate, everything's sitting on, because the bearings keep popping out, and that's not good when it's going fast. So And that was before I greased it up and everything. Oh yeah, I just did that one-handed. All right. So, and then this is very specific. So the rotor goes counterclockwise, I think. Wait. Yeah. And then the stator rotor goes the other way. And the diodes can direct you um, on like which direction it's supposed to go. It really doesn't spin the other way. And I think it's because I put diodes in it that it spins the directions the diodes are going. What's up, Mike? Yeah, man, that thing, it whips now. I just had to lower the rotor like a quarter inch. But I think the batteries are like halfway depleted by now. I've been playing with it a lot, so gotta charge them up. Oh yeah, man. 12 volts won't get you here, but 24 definitely. 36, you're gonna need resistance. Oh yeah, I know. Heck yeah, and I'm thinking about changing my standard shaft size to at least 8 millimeters. I mean, I have 10 millimeters over here on this other table, but I don't mind that it's rocking a little bit. I mean, flexibility when things are tall is. Um, I think it comes standard. Actually, things blow in the wind, man. That's just the way things are. But yeah, like I said, these shafts, these 10 millimeter shafts, are so like more sturdy. Nah, man. See, I get a 1 inch shaft, and then I gotta build a 5 mile coil, and I don't want to do that. No, I'm kidding, man. Yeah. So a whole inch, man. That's crazy. Let me get my bar over here. This is I got an inch right here. It's not really a shaft or anything, but that's an inch. Holy cow, man. But a half inch, I get that. That's just a little bit bigger than 10 millimeters. So that's been running for quite a minute now. I will have to charge those batteries. And I haven't hooked up the third battery yet. I'm just using it for weight balance. I think it'll blow all the transistors and everything if I put the third battery in the breadboard. Yeah, yeah, I totally agree. And then when I get enough loot together to, do that, well, I do. I have the 10 millimeters already hooked up. Like it's already ready to go on a totally different plate. I think that's what I'm gonna do. That's solid. This isn't coming off though, so that's might be a problem. Yes, absolutely. And this right here, it was the print. The print kind of curled up on one of the corners, making the hole some not straight. So as soon as I get those out of there, I'm going to use iron infused PLA to print a holder again for the magnet. It's a nice magnet. And I think then my poles will actually be straight instead of curved, like, because you can't really tell. Or I don't know. I'm just pretty sure that it's the print there that's kind of curled up on the corner. All right. So the ferrite magnets, I really do want to do something with those. Pillow blocks, huh? I got a few of those. No, it's not. It's not that much work. It just costs money. It's a lot of work in the regard that you have to make that money. But yeah, I get what you're saying. The stability is obviously visibly blowing in the wind. Yeah, I'm not. Yeah, I get it. But I mean, it's like a slide. The list is like a slide. And it like gets just longer and longer. It's like a water slide down in Florida. You know, you think you're at the bottom, but it's like nope. um, but like all in all, Mike, how much do you think this would run me to build a a unit like you're talking about? Because I mean, once you change the shaft, you have to change everything, and it's going to cost a lot of money. But I got this, and I think this will do me for what I'm doing. Oh yeah, yeah, I made a pipe bearing. Yeah, I made one of those thingamabobbers. I had a pipe, and then I had a bigger pipe on top of that pipe, and one pipe was clipped to one thing, and the other pipe was clipped to another, and they could spin in opposite directions. It was one of the things that the first bearings I like designed for the counter rotator. I was like, how is this going to work? And that's what I came up with. I didn't know that it was already a thing. Well, I assumed it was definitely like, because it was so easy to do, like to put together. And it was very rudimentary. So, you know, like just a pipe inside of a pipe. Sure, there's better versions of it. Yeah, I did that before. I bought a set of training wheels. Oh, train wheel. I thought you said training wheels. No, I was going to use training wheels. And they didn't work out too well because the bearings sucked. All right, so I mean, like a train wheel. What? I mean, yeah, I get that, but it's like what I would need to move that is going to be at least, you know, 5 miles. At least 5 miles. What would it take to move something like that? Just could I move it with this coil right here? I think if the bearing was good enough, I could move it with this coil. Oh yeah. Hmm. All right. So I'm gonna turn this on. I'm gonna go over there. I'm gonna take the aluminum disc off for right now. That's what you're gonna do, Mike. You're gonna make the big flywheel. Which orientation are you gonna use? Yeah, but like, are you gonna use it like Price is Right or Wheel of Fortune? Ah, so your shaft would be up and down, yeah. So Price is Right. Yeah, Price is Right. That's cool, man. Heck yeah. That's how Adam, the dude, man, did it. The huge one, man, a huge aluminum disc, and it got going really, really fast. But he was using a pulse motor to speed it up. Are you gonna hook that up in your backyard? Ah, I see. Sweet. And you're gonna use that to like power your house? Maybe sell the electrical company some juice. Like, here, I'll sell it back to you. That sounds like a plan, man. I love how like vivaciously this thing spins, man. It's great. Oh heck yeah! But like I was saying, Mike, do you think this coil could move a train wheel? It would move it like really, really slowly if it could move it at all, right? Oh, I see what you're saying. Yeah. Yeah, probably. More than likely you would have to do that. But I think there's a way that you can put a resistor that's small enough to bridge the base and the collector, or the collector and the emitter. You can trigger that to be on more permanently, but I don't know if that'd be a good thing. Oh man, I had it in my head, and I know it would work too, because I've seen it in different format. Yeah, I mean seriously, if you got it going up to at least a certain amount of speed, it would go all night on its own, wouldn't it? But that might be dangerous. Right, right. And then you know, I'm getting real interested in the other the flip side of magnetism, like all the cold energy and stuff. I'm gonna try and attempt to build a Tesla coil. I need to know a little bit more about what the specifics of what's happening in a Tesla coil before I like attempt to do that. So I can decide what I want the gauge of wire to be. So I can decide how many turns I want it to be. Somebody's already like found the resonant frequency amount of turns that you need for the proper gauge and everything. I don't know if I want to do it that way. I might. I don't know. I'd probably pay good money to get that information. Actually, some from somewhere. Oh man. But yeah, I understand that the primary goes around the tube, and so it's a cylindrical primary, and then the secondary is much different size, and it goes around the outside. Now I don't know what each one of those do. I was told that it would take like 3 or 4 connections, so I'm waiting on the money to get a soldering kit, and then we're gonna go from there, straight up. Um, and I'm gonna learn. I feel like there's like an unnecessary struggle between hot and cold. Uh, I don't see the need to, you know, disrespect either one. I think this is cool. I think what Mike here is describing is cool. I think the other side of this is cool. It's all good. And it's like I don't understand like what the problem is. I think this is great. And I think if I had a Tesla coil right here in the middle. See, I got this big quartz crystal, man. It's like, and it's natural too. It's natural quartz, and I was thinking about wrapping it in like some copper and placing it in some water, and then doing the Tesla coil thing, seeing if we can't transmute the two together somehow. Because I heard transmutation is a thing. So yeah, I say we start there and trying to utilize what we know instead of just totally disregarding it. You know? And I don't know, like I feel pretty good. I'm eager to learn, but I don't know. Um, I am, kind of defensive when it comes to just basically what I'm doing. Because I'm having fun, man. That's what I'm doing. It's like somebody's over here telling me that I can't do that. I'm like, really? I think this is more right than most other things are, is to have fun, right? Especially not at other people's expense. That's wrong. To have fun at other people's expense is not right. What's that, Mike? Can't do what? I already forgot what I just said, man. It's terrible. No, it's not like that. I don't know. It's so vague too. It's like very vague, and it's like, but it feels like I'm being poked at. But it's like a vague statement that could generalize to anybody. But it's like, yeah, that's what I'm doing. What's the big problem with it? What's the big deal? I think it's fun, man. I think it's great. Just the fact that this is going this fast, it's only 9 volts in, and I can switch it between axial flux and radial flux basically whenever I want. All right, yeah, no, and honestly, I do. I feel very loose, like a loose cannon sometimes. That's what I mean to say. I don't want to fight with anybody really, but I mean, sometimes I feel like I hear fighting words. Honestly, it's like, hey man, chill out. And I've always like I found it that even with the right to free speech, there's a double-edged sword there. There's a double standard there. And I mean, if the drones and if crime goes down, the drones take care of war and all that, then the right to bear arms is just pointless in my mind. It's just a toy that you could really hurt somebody with. Somebody didn't like that about guns, but that's all right. I don't see the point if what we're heading to is an era of, peace and prosperity. Why do we need weapons? Or is that not where we're going? Do I got it wrong? Are we not headed to a better place right now? This is a pulse motor. It's axial flux. It is all north magnets facing up. There's 4 magnets in here. And we got a counter rotating pulse motor over here. We are definitely looking at Faraday's disc. I'm trying to make it work here. I got to make a brush commutator for the edge in the center of the disc. That's what I got to do. We're having conversations about random stuff too. I mean, if you got some stuff you want to talk about. All right. I just, I thought we were headed in a peaceful direction. Yeah, I understand. Well, I mean, I don't understand necessarily, but here, yeah, because you got everybody like, but I don't know, man. That would probably enrich your life quite a bit. Am I wrong? Thanks, Mike. So I need to find a way to solidify this disc, make it so it's stationary. And then I got another rotor to go on top and sync up with the one on the bottom. And then make the brushes, one for the center, one for the outer rim. Yeah, totally do that. I honor, I love, I cherish my family. Um, Even though, my family has got a free spirit. That's all I'm going to say. It's a beautiful thing, man. Yeah, that's what I'm looking for, a bearing lock. It's kind of like a pillow block, but it's just a bearing with a little nut in it. And clamp it on there. See, now what I've compiled is a list of things that I'm going to need to buy to transform what's going on here. And I think some flat plywood will be where I'm going to start, and then I'm going to raise it up probably close to a foot, maybe a half a foot. Half a foot, yeah, that'll be cheaper than a foot. And we're going to decide exactly how we're going to do that. I think we're just going to use the plywood. We're not going to reutilize any of this pegboard. And we're gonna get a more concrete presentation going here. I mean, if I want to like shift things out and do what I'm doing, I do it on this. But the new table is going to be, like one project at a time, basically. That's so neat. And what's awesome is that it wants to do it. It just, and yeah, it's going to scoot along at a slower pace, the bottom one, but it's scooting along is what I'm getting at. It is moving in the opposite direction. And as far as I know, I don't know if what I have to do is put more weight on the top part. Maybe get stronger magnets, put the weight on the top part, and have the weight equal out on top and bottom, not just on all sides of the bottom part. And then we'll get a real, look at it, what it's supposed to be. But I think that weight has to equal out. And you got gravity, which is playing a different role on both of those parts. I do have another pegboard there in case I decide to refurbish this table. All right, so now both of these coils here, this one and the one that's underneath doing axial flux right now, are hooked up into 1, 2, 3 circuit. So you got 1 for the base, 2 for the collector, and 3 for the emitter. And then it's grounded. And it's nice and quiet. I mean, picks up speed really good. And granted, it might draw a few more amps than another circuit. And what I mean by that is like 200 milliamps max. Oh man. So I really, if I'm going to go high on the shaft, it's got to be thicker than it is right now. That's for sure. But I love the axial flux and how much power is going through this thing right now. 12 volts in. Wow. So actually it'll be kind of difficult to switch this disc. Because I put this little cover on the magnets so that it would not attract up when I put the other rotor on. It works pretty well. Yeah, that thing weighs at least a pound. Maybe a little less. Have it flopping around on the top, it's gonna go everywhere. I'm gonna get some tin foil and get some useful data off of this. Alright, let's get a... Get a reading on that. There we go. Now with this stuff, I made a bunch of commutator plates to run counter-rotating pulse motor. Just a positive and a negative plate for reed switch that would operate at 100% duty cycle. $1,900. 10.5 volts in, drawing about an amp altogether. $2,000. $21,500. $2,200. $2,237. $2,256. Okay, I think 2,200. Maybe right around where we're gonna chill. Okay, that's not as good, but it's pretty good. And then if we have the other coil on there, or another coil on there, God would be that one. Want it to be more the same dimensions as the other one. Nice. And no, man, I'm glad I don't say everything. I say what I think I need to say, and then everything else I just gotta let it fly through your head, man. You can't. I mean, some of it you can embrace, because some of it's good, but there are, stuff you can't embrace, don't embrace it. there's gonna be stuff out there that you told yourself that you weren't gonna do. Like for instance, the soldering kit. I've realized now, I've come to this point where if I don't get one, I can't really do anything else. I've reached like my limitations with what I can do. I need to reduce, and the only way to reduce farther than what I've got now is by having a soldering kit. And I told myself I wasn't going to do that because, that just increases now the chance that we could have an accident. The more tools that deal with heat directly, it's like there's another risk involved with that. And I don't have a garage. I have a little shed. It doesn't have a light in it. That's why I do it inside. That's why I do it here. And I don't mind doing this. And I guess I'm not going to mind doing a little soldering kit. I looked at it. It doesn't looks pretty harmless. As long as I, just don't leave it running or something. That should be alright. But yeah, it's like I told myself I wasn't going to do that, and now I'm finding myself needing to do that. So am I compromised, or do I just let it go in one ear and out the other? And like this is one of those things where you can't really read too much into it. You gotta let it go in one ear and out the other. And just everything you're telling yourself why you can't do something, get rid of it. And then if you're, seriously, there are some things, and I don't know, a lot of people would disagree with me, that people say, and they don't even need to be anywhere near saying that. And I think it's like part of being an American, at least, I'm not saying like, well, that's a great generalization. Our freedom of speech, I think some people take it to a level it's not supposed to go. I do. I think they take it to a level that enables them to possibly truly destroy people's lives. And it leaves it totally on that person that just got his head ripped off by this other person to suck it up. And that's the other American dream, to suck stuff up. You gotta suck it up. Move along. Either you suck it up or you dish it out, or I don't even know, man. But I feel like there are defined roles, and you have to become good at doing them. And believe me, man, people love a person that can suck it up. They really do. When I say suck it up, that means be in the midst of total chaos and not react to it. That's what I mean by sucking it up. And that's important. I wish I had that skill more, in tune to me. It's not part of who I am currently. You think if I was embracing those philosophies, I'd be having this conversation to begin with? I don't know. At least if I was having this conversation, it would be under a different light. I wouldn't have made previous choices that I made. I wouldn't have done those things if I, was more grown up and I took it more seriously. I wouldn't have done the sabotaging things because I can handle it. It's not a big deal. I can handle it. It's just that I screwed myself over. Most of the time I'm screwing myself over. The rest of the time it's like, dude, you need to go on somebody else's lawn, kind of thing. And that happens very seldomly. People are awesome. Lots and lots of people are really, really cool. And, hopefully one day I can find myself amongst those ranks. But, a lot of things have to happen. Like, I have to learn when not to open my mouth, and I never learned that, you know, this conversation. Short, small example of, you know, that lesson. And it's truly valuable to learn that lesson. I'm not trying to teach a lesson. I'm just saying that lesson would have done me wonders. Would have been awesome. But, you know, I got my own deficiencies too, man. I'm learning disabled. I can't learn but like 2 different ways, and I'm really selective. It's very hard for me to learn past what I know. Extremely difficult. I do it though. I mean, all this stuff beyond what I knew when I started doing it. I learned all this stuff. But, you know, it's like rudimentary. It's not, you know, let me get the, it's not like awesome circuitry, you know? And I'm not beating myself up, man. I think I've come a long way. I just think that if I, you know, had that ability, I guess it's called applying yourself. And I do it. I guess I can do it. I just don't do it that often. I feel like I feel very negative towards myself a lot of the time, and it gets in the way. And I feel negative towards, you know, people that I feel have done me wrong when they have absolutely done nothing wrong. And I jump to conclusions a lot of the time. That gets in my way too. I'm just saying that all these things will get in your way of true progression in your quest, my quest, the quest. And it's like I am talking to myself. So if that, you catch me with a couple of U's in my I statements, that's just me talking to myself. And you can choose to listen, or you don't have to, but I don't know if that's going to stop me from continuing this conversation. I just love that out of what somebody taught me about a year and a half ago, I can make a motor run. I've been doing it for about a year and a half, just like this. And then, you know, I always knew there was more advanced stuff because I've seen the inside of a VCR before. I know that sounds like different, but yeah, I knew that this is just about as bare bones as you can get it without destroying the stuff you're using. It's 1, 2, 3 right here. So you got resistance, you got your trigger, you got your drive, and you got your power. Bing, bang, doing. I feel that like it's not heat, it feels more like almost like a static feeling, but it's not. It doesn't feel like it's going to shock me. it's all very grounded right now. I don't know. Because I heard that the fields that I'm working with, these magnetic fields, are not the same magnetic fields that you can travel through time with. They're not the same as far as, I've been learning through watching various YouTube channels, Old Man Builds. Yeah, I don't know. I was told otherwise. I don't know though. I really don't. I've learned all that I know about this stuff on YouTube. Either somebody on YouTube directed me to search somewhere, or they gave me the data themselves. All the information basically has come from YouTube though, and it's pretty crisp, it's nice, it's solid. I'm making real stuff happen. So I'd say most of it's legit. At least, I mean, I guess there are some, I don't know, I've seen like debunk videos and all that stuff. This doesn't even fall in the realm of me doing anything clever like that. It's like so simple. Yeah, I just really like messing around with magnets. It's truly amazing sometimes. Now, there is one thing that I am truly amazed by, and that is the magnetic field that is being discussed or just talked about that can do magnificent things. It's each path. I saw it with water. It was demonstrated with droplets of water. In the magnetic field is a single path that never ends, really. So, and each one is on a different path at a different time, but it's always continuously flowing. And it never flows the same way twice. Okay, so it's always going, and it never flows the same way twice. So it's always going in a different place, but it's always around the center. That was really cool. It was very, very neat watching that. So, yeah. If I can, get into doing some of that stuff. But I don't know. I think just need to bury that hatchet, and just look towards the future in a more bright aspect. So cool. I'm mesmerized right now by this kind of rotator. It's like, it's satisfying watching it spin. Now when I had all the magnets facing outward, and on the bottom one, and all the magnets facing Halbeck array on the top, I would spin, I'd do a counter rotator, I'd spin the bottom one this way and the top one the other way, and it would sing. The aluminum disc would like, it would sing. It was awesome. But I only know that orientation currently where to do that. Oh yeah, those batteries got to be getting close to cashed. Heck yeah. Man, that was awesome though. I truly think I was onto something, I don't know what, but when it was making that sound, because it was like the magnetic field force was scooting, like scraping along the disc, and it was making like a, like when you drag your finger along a wine glass or something, making the sound like that. Well, I might as well set it up completely once, real quick. So I guess I'm going to lower this just a little bit. And I'm not stripped. It's not good. I think I'm going to need a dual drive, though. There it is. And this is why I put the little flap on here to keep all the magnets in place. Hopefully it'll work. Oh, that's not right. Needs a little bit more down. And then I think I'm gonna need like just put one of these iron poles in here for now. Okay, so those are pretty synced, but that's with the motor off. And so that's the idea of the Faraday disc, but it's an inverse version of the Faraday disc. Instead of spinning the conductor, we're spinning the magnets around the conductor. So I'm gonna need a clamp or something for this aluminum disc. Stiller that stays, the more energy we'll get. There it goes. Alright. So this is like 5 volts in. Now, since I'm doing it through sinking and through an aluminum disc, it may still be too high for it to sink properly, too far away. But it kind of grabs it, and that'll spin for a while. It just won't spin at the same speed, which I'm kind of aiming for. So I think maybe taking a centimeter away from that gap and a centimeter away from this gap, maybe a little less, maybe like a millimeter. And that'll put it a little bit closer, and that should do it, because it's kind of working right now. Nope. So definitely needs to be a little closer. And this is all right. To figure it out now. There it is. That nut is good. Very tight. Now I think that aluminum disc is going to get in the way, but we'll see. So we'll get our contact for the center and our contact for the outer edge here. Oh yeah, that's way too close. Might have to let it spin. I don't know. Because when you stop it, it's definitely a break. It's close enough to break it. I don't mean like broken, but I mean like stop it. But I know right now that it's spinning slower than the other two discs. And the top one and bottom one are more synced than they were before. They're all more synced than they were before. So I need my two brushes, and I was thinking about using this kind of this right here for the brush. Maybe dip it in some liquid metal of some kind. Yeah, that'll be fun. Yeah, I need to up that a little bit. Because if I don't let it spin, That did get pretty hot from the friction. Maybe it's just my hand. I don't know. Can't really tell. So if I use it like this, and then I put stationary magnets on the top, that might be better. I'm going to try and put second drive coil underneath here. Oh no. Okay. Yeah. Oh yeah. Here we go. It might not be high enough. Should be right, but maybe not, because it's a lot smaller. Elevate that a little bit more. That coil. So I might take this breadboard maybe. No, too much. So take this out and try this. Huh. Yeah, I think this is going to be the one. Like, there it is. Oh man, this coil is really unstable. I think it's definitely because of the way I put it together. There we go. I'm only drawing 100 milliamps. It doesn't seem to be right to me. So I know there's something not right. But I have a solution. No, there's no iron infused PLA in this one, so we won't have the. Let's see, it should be all right. There we go. Dual flux axial drive. Yeah, that sucks. The axial is just riding too high. Wow. So fun though. It's a lot funner though when it's like not doing that. Shaking, I mean. So yeah, we were discussing thicker shafts. I'm gonna definitely be doing that. Yeah, I'm gonna take it easy. Thanks for hanging out, everybody.